All righty. We are recording. One guest waiting. Who is waiting?
Shit.
What's the matter?
I wanted that to be the first thing the transcript said.
I appreciate that. Thank you. All right. For those of you that were not in the class last week, that explained what the bird Sitehawk is. So just a quick refresher. This is the tool when you have any type of a comm issue, whether it's VHF, HF, UHF, it doesn't matter. Anything that has a coax and an antenna, this is the tool that you go to. Last week, if you didn't see it, you can rewatch the video on the shared drive. We talked about theory and how this actually works. Today, we're going to talk about physically setting the unit up, and I'll show you as much as I can. I don't have any test antennas here, but then I'll play two really short videos afterwards to just show you what it all means. So when you get the box and open it up, there's going to be two trays. The top tray is going to have the physical unit itself in it, and then you pull that top tray out, and it will have the, give me 1 second here, it will have all the adapters, the coax, and I'm just switching my microphones here. All right. It will have the adapters, the coax. This is your coax lead. This is a calibration tool. We're going to go through all this. This is a 50 ohm dummy load, and we'll explain what that's for. The adapters you're going to use, this is the whole adapter set that's in here, so you can adapt the ends of this or this to anything that you need. Usually either this small one or this one are going to be the final ones that you plug into the rack. And then the rest of these, you're just going to screw into the ends of this cable to adapt to this or what have you. But full adapter set works really good. The unit itself, this is the bird Sitehawk. Kind of looks like a fat cell phone, okay? And we're going to go through the whole setup on how to turn it on and everything else. Okay, so that button here on the side, on the bottom, right here where my thumb is, just going to hold that down. It's like a normal phone. Let it go through its boot up process. This also comes with a stylus in the box. Stylus makes it a little bit easier. Some of the touch points on the screen are a little bit small. Atlas has multiple of these throughout their system. So getting one should not be an issue. Okay.
Just making sure it's charged when you get it.
Make sure it's charged when you get it, because they will never, ever, 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 ever charge it.
Yeah, 100% be dead when you get it.
Yes, yeah, 100% will be. Okay. So when it first boots up, now, if you get one from Atlas, it may boot up to a screen before this that says, I believe it's something like simple or easy version. Don't ever click on that. Never had luck with it. I don't think the settings in it are right, and it crashes a lot. Always click the advanced version. It's going to take you right to the screen. And I'm going to show you how to set it up. It's not difficult. The first time going through it, this is going to be a lot of info, but the video is going to be here for you to rely on, or call me. I can walk you through it. After you use this a couple times, it's not hard at all. When I would use this, when I would travel, honestly, I would only use it once every 6-8 months, and I would have to relearn it every time I did it. And again, it's not hard to do once you do it a couple times. Once you have it in your hand to play with, it's not difficult. So after you get it booted up, You're going to come to this. This is the main screen it's going to boot up to. Okay. First thing we want to do is we want to connect our short lead for our coax that we just pulled out of that box. Very simple, just screws into the one side. Okay. And now we want to do our settings. So when you're on this, the easy thing to remember is you're going to do settings from the right to the left. The settings are up here at the top. This is going to make it tip. I just want to make sure you guys can see. Okay. So we're going to start from the right to the left here. When this first pops up, you're going to see system. System doesn't really do much for us. We don't need to worry too much about that. This PNG is a screenshot, so you can click on that. It'll take a screenshot and store it. The next one is frequency, which is going to be our first setting. I'll come back to I'm sorry. The next one's file. Frequency is coming up. File, when we watch the videos, he's going to talk about loading the files from here. It all depends on whose Sitehawk you're using. This one I have here is V1s. When you're using Atlases, I wouldn't depend on loading any files. So I'm just going to show you how to manually input the stuff. It's simple, but just FYI, the video we're going to watch in a little bit is going to talk about coming here and loading the file for whatever antenna that you're doing. So don't worry about that right now. If you start messing with this and you're like, oh my God, I don't know what I did. I'm kind of getting into it and I think my settings are wrong. Here's a reset. It's not going to hurt anything. It's just going to reset all the settings to default. Okay. And then you just start over with your settings. This last one on here, we're going to skip frequency for a second. This last one on here is just a memo. We don't even worry about that. We're never really going to use that. So frequency. We're going to set up our frequency. So mainly we need to figure out what we're working on. Okay. So if we go to the AMM, Chapter 20, there is a whole section for doing coax cable and antenna system inspection with a frequency domain reflectometer, which is what this Sitehawk is. This is an FDR, frequency domain reflectometer. In this section, it's gonna walk you through how to actually set this thing up. Okay. The main thing that you want to know, especially after you get used to this, is our settings. So for today's purposes, we're going to do VHF, just so you understand how to do the settings. The main things we're going to worry about here are our system operating frequency. In our case, for VHF today, it's going to be 118 to 137. And then what our limit is. In this case, our maximum standing wave ratio or return loss, depending on which one we do. And we're going to do the SWR. I'll explain that in a second. So it's going to be 2.0. Okay. So when we're looking at this, you can see 115 to 137. Now there's two different ways to do this. We just clicked on frequency. We have our start. So we're going to click on that and you can look and it says 118. This is all pretty self-explanatory when you get into it. And our stop is going to be 137. You can also set this. You can see our start frequency here at the bottom and our stop frequency here at the bottom. And we also, in our frequency, I forgot to do it. We're not worried about the center. We're not worried about the span, but our points is really our resolution, how fine our points are going to be that it's going to plot out. So we usually go right in the middle. 801 is pretty much a standard for whatever we do. So we just set our frequency up for VHF, what this is going to scan. So this is going to scan, this is going to send a frequency of 118 megahertz to 137 megahertz. It's going to scan that whole frequency through this whole coax cable and our antenna, whatever that we're doing. Okay. You can always, there's shortcuts here at the bottom. If you just click on start, and then you can put it in directly there if you want. But it's easier to remember right to left on this menu, and that's how you do setups. So we did this, we did our frequency. Now our next thing over here is cal. Anytime you change the frequency on here, you need to do a new calibration. And how we do a calibration is with this calibrated load, okay? So this calibrated load comes in the box. All we're gonna do, you can see on this calibrated load, it has an open, a short, and a load. So open, load, short, and we just connect that and hit the button. So in our case, the first one up here is open. So we're gonna take our cable that we already connected, and we're gonna go to the open one. We're gonna screw it on there, snug it, take our thing and click open, and it's gonna calibrate it. When it turns green, we move to the next one. Usually this is something you only have to do once when you're going out to test something, but if you are gonna change frequencies for whatever reason, you do have to recalibrate it. Because what it's doing is it's calibrating it for that frequency, but it's also taking our lead. This is about probably an 8-foot, 10-foot lead. It's going to take our lead in and take that out of the equation and calibrate the whole thing with our lead in it. So in this case, we're doing short. So we're going to click on short, give it a second. It's going to turn green. And then we do our last one, which is our load. Okay. Click on load. It's going to turn green. And now you can see this turn to correction on. And down here in the bottom corner, you see in amber or whatever color that is, correction on. So that means we are calibrated and we're ready to move on to the next step. Okay. So again, moving right to left, we did calibration. We're going to set up our distance default in case we have a fault. So there's a few things we need to know for this. Okay. First of all, what our system today, our sample system is going to be a 747 VHF left. Let me do that first. So VHF left. This is our system we're going out to test. What we're going to do is on the wire diagram is we're going to find out what it is that we're testing. So down here at the bottom, this shows our coax that goes out to our VHF left. So this is our coax line that I highlighted, and you can see here's the receiver on the equipment shelf. Here's a short coax going to this first connector. Here's another coax going to the next connector, and then the last coax going to the antenna. The information that we're going to need for this is the length of these wires. We need to be, for us to have a good accurate distance default, we need to know what the length of everything is. And how we do that is, for example, we're going to take this first section here. So this wire number is 347-451 BMS 1365 0G. How we find out, I've looked this up already, but I'm going to show you how to do it. In this case, it's 2 feet 6 inches long. So how we do this is in Mobile Toolbox. We're going to go to, this is not liking me right now. Okay. Wiring Finder. And we're going to put in, come on. You can do it. Okay. So our wire number started with W347. So we're just going to type in 347, and that'll pop up. whatever has 347 in it. In this case, our wire starts with that. So we're going to click on this. And this is going to bring up, we know we're looking at the right thing here. I don't know why everything just started stuttering on me. VHF left coax antenna stub. So we know that's the section, that last section that goes up to the antenna. So what it's going to tell us here, it's going to give us that wire number, which -451 was the next part of our wire number. It's going to tell us 2 feet 6 inches. And if we need to, just to verify what equipment it goes to, it's going to give us that information here. Main thing we're looking for, 2 feet 6 inches. And everything is stuttering. What? Come on. You got it. Of course, it's going to lock up now because we're doing a class. Come on. Well, I don't know why we are stuttering here. I can't move anything. Sorry, guys. I apologize. Technical difficulties. It worked fine earlier. Is it going to let me move it? Come on. Let me move it. There we go. All right. Let's see if I think we're back. So all I did is went through the rest of these wires. Like we said, 2 feet 6 inches was this first one. I did it with the other two. I'm not going to make you go through that right now, but our total 58 feet 8 inches. So 58 feet 8 inches. Too much caffeine today. What we want to do is to make sure that we're scanning the whole cable, including the antenna, is we want to give it an extra 10 to 20% on our distance. So our unit feet, our start 0, because we want to start right at the beginning, and our stop, in this case, we're going to go to 65 feet. And that's giving us an extra 10 to 20%. Our cable loss and velocity, we need to know that for how fast that is traveling through the cable. And all the coaxes are just a little bit different. It's not going to matter a whole lot, but it will make a difference for accuracy. So there is a cable list built in. We pick what our cable is off the list and click on it. This Sitehawk that I have here has older software on it. I tried all morning to update the software to get a better list. You can always add it in manually, but for our purposes today, we're going to click. It doesn't have our specific cable in here, but it's close to the 400. So we're just going to click on this, click OK, and it's going to propagate our cable loss per foot and our velocity. So if you get to that point and you have questions on that, call me and I can walk you through this. I don't know if Atlas updates their firmware on these on a regular basis. Worst case, we can look up this information and put it in manually. Not that big of a deal. Okay. So we did our frequency. We calibrated after the frequency. We just put our information in for distance default. And now we're going to set up, we're going to turn our limit on. It's going to give us our limit line, which is this red line. And then we're also going to turn our fail flag on. So makes it really, really simple. This is the hardest part. And after you do this a few times, you can go through and do this pretty quickly. This is the hardest part of using this whole thing is doing the setup. Now all we do, we're going to measure this in SWR. That's what we set up for. And then also on our limit, if we go back to our If we go back to our chart in the AMM and we look at that 2.0, so we're going to do SWR. We just changed this to SWR, and our limit is going to be 2.0. In this case, it's already at 2.0, so we don't have to change that, but this is where you would change it. So now we have our limit. We turned on our little red line, our fail line, and our fail flag. So if we were to, I'm going to use this dummy load. So this dummy load, all the coax on the aircraft are 50 ohm coax. So this dummy load is a perfect 50 ohm. So if we plug this in and pretend it's part of the aircraft, what we would get, if it's good on the aircraft, right away it's going to tell us pass or fail. So really simple. After it's set up, you pull the box out of the rack, you take those adapters we talked about earlier, and you just push it into the coax port on the back of the rack. And after this is set up, it's going to tell you pass or fail. And what it's checking is all the coax in that whole system and the antenna. So our if we go back to our wire diagram, it is checking from the box all the way through the antenna. So this whole area here, from the box all the way, including the antenna, checking that coax to make sure if the coax is good and the antenna is good. So let's say that we had a fail. First thing we would do is we would go to scale and click auto scale. And it's going to take us to the highest point on that. In this case, since we're using this perfect load, there really isn't much. But if there was a peak point, we could do auto scale, and it's going to go to the highest point that's on there. We can do marker and search max, and it would take us right to the highest point of where it would go past that fail line. But again, in our case, I don't have an example of it going past the fail line. If it went past the fail line, right now we're sweeping all the frequencies between these for that system. Now we want to, okay, we failed at a certain point. We want to find out where we failed at. So we click on our SWR and we go distance default, SWR. And now this bottom, instead of showing frequency, it's going to show us our distance. So we put in 65 feet. So you can see here 0 to 65. And then we would, again, go back to our marker and search max. And it would take us right to the highest point on that peak. So let's say our line, and you'll see an example of this when we watch the video. If our line went up here, we would know that that is 10 feet in, and we can either go back and see if there's a connector, because we already looked at the wire list and the length, and see if there's a connector at that point that maybe we should go look at and make sure it's not loose, or whatever other fail point. If it's failing right here at the end at 60, well, in our case, our antenna was at right about 58 feet. If the fail was right at the antenna, we would know it's either the connector at the end of the antenna or it's the antenna itself. So then we have a couple ways that we can troubleshoot down even further. If you have access to the back of the antenna, some antennas are easier to get to than others. You can take this dummy load that we have, unscrew our antenna, unscrew an antenna, and adapt this dummy load to the cable, and then it'll look just like it is on here. And if it's still failing, we know it's something to do with the cable. If you put this on right at the antenna, you disconnect the antenna, hook this up, and it all passes, you know you have a bad antenna. The only other possible thing it could be is most of the antennas on the aircraft use the aircraft surface bond as a portion of the antenna, so they can make the antenna smaller. So the other thing that we can do is we go up and actually press on the antenna while this is hooked up, because this is an active scan. It's still scanning now. And I've seen it many times. You go up and just push on the antenna and it goes from fail to pass. And now you know you have a bad bond on the antenna. In which case we take the antenna off, we get a new, they have these, if you're not familiar, there's like a gel crush gasket that's got a metal mesh embedded in it. Put a new one of those on, screw the antenna down, torque it, good to go. Passes every time. If it's not, and let's say it's somewhere in the middle and we're not 100% sure, one other thing that we can do is we can do a very high frequency test of the whole coax. So before I get into that, let me stop there just for a second and let me ask does anyone have questions? I know I throw a lot of information at you right now. Does anyone have questions up to this point? Feel free to speak up. There's no stupid questions. So if you do, ask.
No, not yet.
Okay.
I just want to, if y'all do have trouble setting that up, just call Christian.
Yes,
I'll
100%.
help set it up. So that is the hardest part.
And really being very serious from experience, after you use this thing or get hands-on and do it a couple times, it's not difficult. It really isn't. It seems like it's a lot now, but it's very simple. Again, always remember, just go from right to left, and it's easy. Just do every section. And the information that you need to put in there is in the wire manual and that chapter 20. The chapter 20, doesn't matter what aircraft, is always going to give you the antenna specs. And to be honest with you, it's the same for all the aircraft. It just changes per system. So VHF, ILS, it doesn't matter. If you pick that on a 4.7 and a 6.7, it's gonna be the same frequencies, the same stop limits, all that good stuff. Okay, so the high frequency scan of the cable is honestly pretty cool. And the only thing that we're going to change to do that, we're going to go back to SWR. We're going to change our frequencies. So we're going to go to microwave frequencies. So we're going to go 5,000 as our start and 6,000 as our finish. And what this is going to do, probably saying I don't have something on there tight enough. And we may have a kink in our cable. We're a little bit screwy here with my setup because I have it set at 65 feet. And obviously I don't have 65 feet of cable here. So the readings you're going to see a better example when we watch the video here momentarily. It screws us up a little bit when we're doing it this way. But when we put this on here, what it's going to do is give us a really high resolution of the cable. And you will see, if I had an actual setup here with antenna and multiple connections in the cable, every connection in the cable, you would see a peak. And when I did this earlier, I think I did 0 to 5,000. Let me do that. Maybe you can see a little bit better example with my setup. Yeah. Again, you'll see a better example on the video. It's just my setup here is not going to be good. But what this does, it acts a little more like a TDR, but it scans every inch of this cable, and you can see actually if a zip tie is on too tight in the coax, if the bend's too tight, you can see every inch of this cable, and the resolution is amazing. I wish I had a better setup to actually show you with this. Keep that in the back of your mind that there is a one more way, this microwave setup. Call me the first time you do it, and I'll walk you through it. But it's not hard to do either. And when you have a real setup, you can see it's pretty amazing on what you can see on this. So to recap, what we did is we turned it on. We went to the AMN chapter 20. We found our first of all, we found what we're going to be testing, which in this case was the VHF COM left. We found out what our links were for our cables, what type of cable we had. We went to the AMM chapter 20. We know we're working VHF. With the VHF, we found out what our frequencies were and what our limit was. We put those into the Sitehawk. We plugged it in, and it told us pass or fail. If it passed, we're good to go. We know we can move on, and it's probably a box. Most of the time, mains control is going to make you change a box out anyway without even doing this. But if this is a recurring problem, when you go and get this, set it up the first time, it might take you a little bit longer to do, but after you get used to doing it, it won't take you more than a couple minutes to set up. Plug it in, you know right away whether it's the coax, the antenna, or the box. Very, very simple way to troubleshoot this stuff. So we input the data into the Sitehawk, go test it, and then we're good to go. So,
and how could you tell the difference between if it was the cable or the antenna?
So it's going to be it's going to depend on the distance. So
okay, right.
When you get a fail, you're going to right away go distance default.
Yeah.
The distance default. And I'm going to show you in the video. I wanted to play the video last, that way you can see a real example of what we just did. When you do distance default, we put in our example, we put in 65 feet. We know we measured and we were 58 feet 8 inches. If we look on our screen with distance default and it's failing right at 58 feet 8 inches or 59 feet, we know it's the antenna because the coax all tested good. And if you can get to the back side of the antenna, a lot of times it's difficult, but if you can, we connect that load that I showed you that's in the box, connect it to the end of the coax, test it again real quick, and it's giving it a perfect load. So it will immediately tell you pass or fail, and it's going to be ideal conditions. So if it doesn't pass with that perfect load, you definitely have something going on with your coax.
Got it.
A lot of times you'll find that very end, I don't know the difference if it's water getting in somewhere or what, but the more you do this, the more you're going to find a lot of the problems are right at the antenna, and the coax ends at the antenna are always severely corroded for whatever reason. I mean, the antenna sealed, you wouldn't think it was water getting in, maybe it didn't seal right, whatever it is, but you'll see that quite frequently, and that end, that last little section of coax is usually screwed up. The other thing you'll see a lot is if the coax runs in an area like the ends of the rack where maybe it can possibly get stepped on, or someone got pretty aggressive with their bends, there's definitely a minimum bend radius with the coax, and if you exceed that, you will screw the coax up. We talked a little bit about that last week when we went into theory of how this works. But just things to keep in mind, even like I said, zip tie that's too tight, or a clamp that's too tight. This is stuffed into a clamp with a bunch of other wires, and the clamp was too small, and they just squeezed it and gorilla wrenched it down. Could definitely cause issues. Things to keep in mind as you're doing this to actually find, if you have a fault, what the fault could possibly be.
You could also find out that C-Check swapped the cables.
Yep, the very first time we used this, they had been trying to troubleshoot a problem in Miami for a couple weeks, and what we find it, I mean, with me teaching how to use this, we still found it in what, an hour, and trying to teach 4 or 5 guys all at once on how to set this up and do everything else. So this really, when it comes to coax, anything with a coax and antenna, this is an amazing tool. It truly is. So let's switch over to why is my Give me just a sec here while I work through my technical difficulties. Here we go. And this should give you, there's two short videos. They're both about 4 minutes long. The first one is going to talk about just using the FDR, and the second one is going to talk about using that microwave setting to do high resolution.
Today we're going to cover the frequency domain reflectometer, the FDR. The FDR is used to test antennas and coax cable, and it's something that we need to do quickly and efficiently. So this tool tries to simplify and automate many of these processes. Now I'm going to, as an example, test COM2, communication 2. It's an antenna, and it's testing between 118 and 136 megahertz. Right now, I'm going to show you how I pull up with the file cabinet. I pull the file for VHF. And you just simply scroll through, select it, load, and when you load, I have the calibration.
So that's what we talked about when we first got into using that Sitehawk, is loading that file. So what we did is we inputted the information manually that may or may not be saved in that Sitehawk. And I would rather have you guys get used to putting the information in manually, because depends on the Sitehawk that you get from Atlas, or if you happen to have the one that B1 owns, whether or not that information is going to be there. So I just wanted to point that back out.
Correction factor is on. So now that we're loaded, I'm looking to make sure 118 megahertz to 136 megahertz is correct. It is. 801 points is the default, and that's just the resolution. Perfect. And now, since I'm calibrated, I do not need to calibrate, but if I did, I would use the calibration T that comes with the unit. Your distance default, I need to ensure that I'm sweeping at least 20% longer, which in our case is about 5 feet longer than our total run. Our velocity of propagation, all of this information comes from your cable list, and you would get this from the wiring diagram. The limit line comes from the AMM, and the AMM is found in the AMM chapter 20. And so you would get your total limit for this system. For VHF, it's 2.0. Last things I need to hit are always auto scale and marker search maximum. So my marker climbed to 118 megahertz. Here you can see right away that at the lower frequencies, the longer wavelength, it's failing. And think of a train trying to jump off up a ramp and off some tracks. I need this train tracks to be perfectly parallel, and when I hit the ramp at lower frequency, it's lower speed, I need a longer ramp. Well, at the lowest frequency, I need the longest ramp, and it's not made. That's a good indication that my antenna is not properly bonded to the aircraft, because the antenna bond is the structure makes up half the antenna. So one good way to test, there's a couple ways. If I have access to the antenna itself, I'm simply going to take an RF dummy load, 50 ohms, connect it to the coax cable, and I have to verify, hey, do I get a pass? So I go auto scale, and I see a pass, and I'm well underneath the red limit line, well below it. So that tells me I likely have an antenna problem. However, as you know, access to the antenna can be quite difficult. So what I can do, if I cannot access it easily, I'll go back to auto scale. My marker is at the maximum. I'm gonna reach onto the antenna and gently pull down and create a better bond. Whether it's within the antenna or the bond to the airplane, you can see it passes. That just nails down immediately. Remember, I can do this in less than 10 minutes on wing to see if I can get a pass and ensure, hey, it's just an antenna bond or the antenna itself. Let's get that on order. Simple.
Questions on that one? No? Okay, let's play the second one then.
Another example is if I test COM1 here, they reported that this is an intermittent chronic problem. So I loaded the same VHF program, same last two buttons I always press, auto scale, marker, search max. This time my maximum is on the highest frequency, the highest speed. I need the shortest ramp. The problem that I'm gonna see at these very high speeds is actually the connections and the cable in between. So even though I pass, you can see that I am very close to the to failing, very close. So I need to take it a step further. I'm gonna load the microwave frequency that you see in the AMM, 5,000 to 6,000 hertz. When I load this program, I'm gonna get a very fine look at the cable. I'm gonna turn this to SWR, distance to fault. It puts this now no longer in the frequency domain, I'm now in the time domain. I do the same things I always do, auto scale, marker, search max. This will tell me the distance.
Okay, so this is what I was talking about on the last thing that we put in there. This is the first time that he's showing the distance default function. But you can see as it's scanning that coax, you see that the peaks, those are usually connectors that you're looking at. You can see one is at a little less than 4 feet. One is at a little bit more than 8 feet. And you can zoom in and get more precise locations. And I think even when you hit, I think it tells you specifically, I can't quite read it on my screen. He's going to talk about that a little bit more. But I wanted to point this out because I was trying to show that to you earlier on ours.
Default. And it's telling me my fault is 3.78 feet at 2.0 SWR, well above the fail line for cables. I'm going to look at this cable about 3 feet. 3 feet puts me in a location right here. So I'm going to simply disconnect and use that same RF dummy load to validate that this cable, this half of the cable is good. And I see right away, this half of the cable is good. So what I'm going to do to test this connector, I'm going to attach this RF dummy load and I'm going to swap out a good interconnect. This peaks right here to ensure my connector to the antenna is good. I check each end of the cable. I'm healthy now at the antenna. I'm healthy at the interconnect, and I have a very good, healthy system. This tells me that even at the microwave frequency, which is a very fine resolution, I'm testing every millimeter as I go through the system. I have a pass. Indeed, it's good. I can now reconnect my system. I can prevent that intermittent issue by simply replacing the faulted RF connection. We sweep the antenna using the operating frequency, VHF. The next step, if I want to look at the cable to ensure I have good connections to prevent an intermittent issue, I'm going to sweep now at the using the intermittent procedure that sweeps at a microwave frequency.
Okay. That is what I have for you guys today. What kind of questions, any questions on anything that we went through today? I know there's a lot of information. There's got to be something. Don't be afraid to ask. All righty. Well, gentlemen, I appreciate your time. I hope you got something out of the class, and I'll see you guys at the next class.